My pleasure, my honor to finally welcome you to Multicore World. With Boku-san, we have been exchanging pleasantries over the years in different parts of the world, and he kept threatening, I will get there, but. I will get there, but. And one day he said, one day I will retire. And well, he did retire from something. Now he found a new job or activity or leadership. And I believe that we will hear about it, but I want to highlight the honor and pleasure to have you here. Thank you very much.
Thank you. So thank you very much for a very kind invitation, Nicholas and all. And so my name is Taisuke Boku. I'm from the University of Tsukuba, basically, but today I will introduce my new job, actually the new project in Japan. And as Nicholas said, that I always wanted to come here, but unfortunately, every year, my university professors and business as undergraduate thesis defense always conflicting with the magical world. So I missed maybe 3 or 4 times of the invitation from the Nicholas, and I missed that. I'm very sorry. Finally, in this year, fortunately, my defense work for the students are just 1 day before my departure to New Zealand, so I could come here. So thank you. It's my great honor to join here. So thank you. So today's my talk is titled as Accelerating GPU Acceleration. So you know that the GPU is of course the accelerator, but we need in Japan, very specially, we need to accelerate our GPU acceleration computing of the supercomputers in Japan, not just Fugaku Next, but our other national infrastructure supercomputers, which is now going to be accelerated by the GPU. And today's main topic is that there is an application development support by the government for the new next generation of supercomputers. So I have still the double title and professor of the Center for Computational Sciences at the University of Tsukuba, which I will retire in the next 1.5 months only. But also, I had a new job, an assignment in the director of the Advanced HPC AI Research and Development Support Center. So this is today's topic, that what is the center and what is our mission and what we are going on for the next generation supercomputing in Japan. So let's look back at the big machine in Japan so far. And maybe some of you, if you're certainly old, you know that about 2002 Earth Simulator System, which is developed by the NEC, and that was a world #1 system with about 40 teraflops of the peak performance. That is about 3 times faster than the previous #1 machine from United States. So that everyone was so surprised and shocked. And Jack Dongara said that, oh, this is the computonics of the world, as the Soviets, the Sputnik almost overcame the Apollo project in the United States. So it was called the computonics with 40 teraflops. So also this is maybe the last gigantic vector machine in Japan, because now you know that only the NEC is continue to making the vector machine. So that is a kind of the national project. And after that, you also know about the K computer. That is the first 10 petaflops machine in the human history. And that is a Fujitsu machine. And it started operation 2011, but the official operation, public application running, it started 2012. So I still remember that the 2011 was a really serious big year in Japan, because on March 11, 2011, Japan east side is attacked by very heavy earthquake. And after the earthquake shock, still there are many factories stopped, but mainly for the electricity power lack. But they continue to develop, and finally they established 10 petaflops impact performance by the Fujitsu, the Spark-based CPU. And current machines, of course, everyone knows that the Fugaku system started 2020, And it's also the Fujitsu's processor, but it is a big change from here to here because Fujitsu, in the history, at first time, they introduced the ARM architecture. ARM architecture and the ARM v8, very specially designed and approved by the ARM for using the SVE, scalable vector engine, that makes very high performance SIMD style of the instructions. And they also introduced a 48 computation core, and it achieves a 488 petaflops peak with over 150,000 of their computation node. But until this machine, they of course use CPU only. And if you look at the top 500 list today, top 10 machine implies only one CPU-oriented machine. That is a Fugaku, still on the number 7 in the world. But all other 9 machines in the top 10 are all equipped with a GPU, especially NVIDIA GPU, but then number 1 and 3 are AMD GPU by the El Capitan and Frontiers. So please remind that the word NFS. NFS stands for the National Flagship System. That is the top tier machine in Japan, and the totally governmental support with over $1 billion of the construction and operation fee. And on the other hand, there is a second tier machines named NIS, National Infrastructure Systems, including the 9 national universities. So there are 9 big national universities in Japan, which is mainly focused on the research of the science. And each of the 9 universities has their own supercomputer center, including my Center for Computational Sciences in University of Tsukuba. So the NIS and the NFS supports the Japanese supercomputing mainly. And so far, that these K and Fugaku led the Japanese supercomputing, and many of the national supercomputer centers in Japan followed to this architecture. But nowadays, it's reversed because first NIS, National Infrastructure Systems of the 9 universities, started to introduce a GPU system, while RIKEN is still running the Fugaku, many-core CPU-only machine. So the next stage is Fugaku Next, which on Tuesday morning, the Satoshi gave a talk about the Fugaku Next project, and maybe my following talk by the Kento-san here, the next talk is also mentioned about the Fugaku Next machine. So anyway, the big change is that finally the Japanese government decided to introduce a GPU system instead of the many-core CPU system. And currently the target year is 2030, around 2030. Maybe I hope that it's in 2029 or something. And another important issue is that so far we mainly focus on the HPC, but the next generation Fugaku Next, we focus on the HPC plus AI, or so-called AI for science. That is a big change. So next a couple of slides I borrowed from the Professor Kondo. He is the leader of the R&D project of the Fugaku Next in RIKEN, as well as he's also the Keio University professor, but his main job is on the Fugaku Next project leader. So this is just a brief timeline, and year 2030 is a target year of the next generation's Fugaku, so-called Fugaku Next, will start the operation. I will skip the other parts. So big change again. So it is a big change of the policy and the strategy of the Japanese flagship supercomputer after Fugaku. And the most important message is that the NFS so far is CPU-only solution for K and Fugaku, but the GPU plus CPU heterogeneous system for Fugaku Next towards a successful HPC, AI, and AI for science. So that is a big change. And sorry for some problem here. So that also, so far, until the Fugaku, the Japanese supercomputer, NFS supercomputer system is called made in Japan, because Fujitsu made everything except the memory. But now it's a change to introduce the NVIDIA GPU as well as the Fujitsu CPU. So the keyword is changed to the made with Japan. Still, we need the Japan some word in the governmental project. So this is a brief picture shown already from the RIKEN, and Kondo-san. And there are currently, this is just a brief design. So maybe the 4 NVIDIA advanced GPU at that time, around 2030, plus Monaka X is a project name of the Fujitsu's next generation many core. The number of cores is still unveiled, but I know some number, but I cannot tell that anyway yet. So anyway, this is a very, very traditional manner of the GPU computation node, as well as many other supercomputers with GPUs. So and also, Fujitsu and NVIDIA make some contract to share the technology to tightly couple the CPU and the NVIDIA GPU. I guess something like NVIDIA and NVIDIA's NVLink C2C for the external chip or internal chip. And they also have some scale-up network because it is based on the NVIDIA. So there is some couple of tens of the nodes can be possible to be connected by the NVLink technology. And finally, also they need a scale-out network like InfiniBand. So this figure is just briefly announced by the Riken and Satoshi and Kondo-san. And the most important thing is that we not much deeply chasing the FP64 vector. So everyone knows that the FP64 vector has some kind of limit, mainly by their memory bandwidth problem. So vector computation is just by the memory bandwidth, and it is reaching to the limit. On the other hand, AI and other technologies is really requiring the small size of the matrix with a lower precision, like 32-bit, 64-bit, 16-bit, and also as well as the 8-bit and nowadays 4-bit. So I don't understand what means a 4-bit floating point or something scientifically, but that is so important to improve the performance of the AI. So all the supercomputers are almost existing for AI today. And so that they target the very high performance around the 600 exaflops by their FP8 AI flops. And maybe the 4-bit AI flops will be also available here. And total power consumption is a little bit higher or equal to the Fugaku machine. Well, the problem here is that so far, Japanese governmental program for the application development mainly focus on the CPU only because of Fugaku and the K-computer are the CPU machine. And on the other hand, as I told you, in university supercomputers, some representative supercomputers already shifting to the GPU. So the university level, we had a lot of program for education or training of the GPU computation. On the other hand, the government didn't support that. So in last year, finally, government next decided to start a new project to support nationwide program of the, how to educate, train, and develop the GPU-ready application. So that is called the Next Generation HPC AI Development Support Organization project, and announced in the July last year. We made a proposal for that, and it is finally accepted. And we launched a new center, Advanced HPC AI Research and Development Support Center, or HAIR-DESC for short. And I was assigned to the director of the center. So that is my second title today. And it was established in October 1st in Kobe and Port Island. That is just next to the Fugaku Riken. So this is the construction of the organization and people. And I'm the director of the HAIR-DESC, because HAIR-DESC stands for the Advanced HPC AI Research Development Support Center. So that's almost making the HAIR-DESC. So I thought about this name before we were selected and awarded to the getting the project. But I remember maybe that is around the ISC time in the Hamburg. It is not yet selected, but then I thought that if we are selected, let's use this name. And also there are three key universities to support, very strongly support the HAIR-DESC organization. One is the University of Tsukuba, where I still belong. and the University of Tokyo, and the Institute of Science Tokyo. So these big three universities are all the GPU-oriented system supporting already. And there are the key person PIs, Professor Nukada from University of Tsukuba, and Professor Shimokawa from University of Tokyo, and Professor Ryo Yokota from the Science Tokyo. So these guys are all the representative top guys of the GPU computing in Japan. So as I told, we have a very strong team with my headdesk and the three universities' core organizations. And there are other 6 universities in Japan who has their own supercomputer centers, like Hokkaido, Tohoku, Nagoya, Kyoto, Osaka, and Kyushu. And all these six universities are also supporter of headdesk project. And the RIKEN RCCS, of course, because the RIKEN RCCS is the headquarters of the R&D of the Fugaku Next machine. So we must have a very tightly coupling with the RIKEN RCCS. And finally, AMD and NVIDIA are also our partners. So we have almost a complete nationwide the team to operate our center. So by the way, maybe you find that there is another company starting with I. And unfortunately, in Japan, and most of the world, so that I company's GPU is not so major. Even they have a number 2 position in the top 500. So actually, in Japan, there is no plan or no running machine with I company's GPU. So at this moment, we skipped that company as a partner. But if they have any new and interesting GPU solution, they are welcome to join to our team. So about the logo, I have not so much time, but then when I thought about the word of the hair desk, I checked it at Google, and there is a word, hair desk. It is a different spell, so don't misunderstand. Last C, and this is last K. And the hair desk, if I Google on the Amazon, this picture is coming. So that this is a kind of the desk for setting up the, mainly the females have some makeup to and the hair making. And also there is some company of the hair making in the United States. That's a Google hit. So I saw that the kind of the logo here. So this is a new logo of the hair desk, and this is a kind of the very speedy and the very active hair, okay? And this inside means the 2 things. One is a device-to-device connection, multi-device connection like a CPU and GPU. And also someone make a remind that this is some kind of the neural network image that supports AI. So I love this the logo very much. And please remind that this logo and the hair desk name. So my joke is that with this hair desk, let's make up yourself for new meeting with a GPU computation. That is the meaning, second meaning of this hair desk, okay? So I'd like to introduce where we are. So our office is located in Kobe. So this is Kobe, and one of the central heart of the supercomputing in Japan, because the RIKEN RCCS exists here. And there is one artificial island named the Port Island, just outside the downtown of the Kobe. If you once visited here, you are familiar to the place. And this is the RIKEN RCCS. And just next station, or just in 10 minutes walk, my office is there as a hair desk office. And by the way, with 10 minutes of the Portliner monorail train, and you can reach to the Kobe airport. So it is very convenient. And there are so many frequent flights between the Haneda airport and the Kobe airport. And after you arrive at the Kobe airport, only 10 minutes by monorail to reach to the RIKEN and my office. Okay, so now let's talk about the contents. So what we will do is that there are 4 or 5 missions. And the first mission is making the standard GPU education course in Japan. So everyone knows that there are so many GPU computing materials, like from the NVIDIA, Intel, or AMD, but most of them are very technical, the contents, and also they're not go straightforward manner of teaching. So let's think about in the university, how teachers teach about the CPU or a many core, a mouth sweat, and something. So it is not just a grammatical issues. So many of the materials introduced, for example, OpenACC directive is something like, and make this effect or sound. But what we are making is that really straightforward text and materials, all the novice person of the GPU computing start to read it and read it, and finally they can understand what is the best use of the GPU computation. So the next one is networking of the old scientific fields. So far, many of the scientific fields are working on their field, but the GPU is a common language in the world. And based on the GPU as a language, they can be networking and crossing over their application fields. And we have many of the workshops, tutorials, and also their symposium to connect them. Thirdly, putting the support on the CPU-oriented applications to GPU. And of course, as I told, most of the Japanese governmental support projects of their supercomputing is CPU-oriented. But now these programs should be changed to the GPU ready for the AI for science. And actually, so I will show later briefly. There are currently there are two programs running, Grand Reach and AI for Science. Both of them are supported by government, but the AI for Science is much bigger than the Grand Reach. And also, since we have 3 core universities, the representative top-level GPU-oriented supercomputer centers. So we also have some state-of-the-art GPU programming or GPU technologies in each of the 3 universities. And finally, we have an international collaboration. Okay, so the GPU education materials. So as I told you, so the most of the materials are the very, they're technology-based or just teaching the content of the programming and the directives. But what we want to do is that how GPU works fundamentally to teach to the older novice person of the GPU, and what is the difference from the CPU. And also the multiple level and the vendors. So we support both the NVIDIA GPU and the AMD GPU in the multiple level, like OpenACC, OpenMP Target, CUDA or HIP, and so on. And of course, including the multi-node solution with how to combine the GPU computation with the MPI program or something. And a good code example, of course, we need. But also, we need a bad code example. So what you shouldn't do in the GPU with a bad code and what is a miserable result. Sometimes it is slower than the CPU computation. That is a very important education. And porting the OpenMP code to the OpenACC or OpenMP target. So here, many of the texts say that the CUDA and the HIP at first. But we teach OpenACC and OpenMP target at first, and CUDA and HIP are some kind of the higher level of the education course. Because nowadays, we are shifting to the more abstraction level of the programming for the GPU, like an OpenACC or OpenMP target. And CUDA or HIP is maybe used for some lower level libraries, which especially require some performance improvement, so that we change the order of the education. And finally, the goal is how to improve the science and the society. So the government strongly requires that not just focusing on the science, but also for the focusing on the society. So for example, one big problem in Japan is now we have a very few GPU-ready people. So GPU-ready means that who can code the GPU? Everyone can code the CPU. But then when we launched our center, the first big problem was that there are very few GPU-ready people. So since we have education, and we will teach all these people shifting from CPU to GPU. And finally, the GPU-ready people are also required not just as a research field, but also in the industry, because the industry also requires a GPU computation. So we are almost finished to build our data storage system to share all the materials and the videos and so on. And all the materials now we are making about in the next 1 month, we will finish to make the version 1 complete material of all these levels of the text and also the materials. And we will collect all the videos of hackathon workshop and symposium, as well as some teaching course or instruction training course. And we distribute everything to the nationwide service. But it is not just on the free publication on the web. We must have some kind of the recording, what I mean, the registration system. And so we will use the current HPCI system in Japan. I will show later. So HPCI stands for High Performance Computing Infrastructure in Japan. So this is a nationwide program. All the supercomputers in Japan with Fugaku and also the 9 National University supercomputers are connected by some big network. And the network system itself and also the registration system is called HPCI. So my HearDesk belongs to another big organization named RIST or RIST. And RIST is responsible for all the management of the HPCI ID. And I mean that most of the supercomputer users in the nationwide program already they have an HPCI ID. And we just use the HPCI ID as a record for any of the education course. And we will also provide most of the GPU-oriented system in Japan, like our university, Tsukuba, has a Pegasus and Sirius. Sirius is our first university's MI300 system, which will start in the next 10 days. And also Tsubame 4.0, everyone knows that. And Miyabi-G is a relatively new system in our joint organization of the University of Tsukuba and the University of Tokyo. This is still the largest university GPU system in Japan. And Aquarius is the University of Tokyo's own machine. So as I told you, that we will use the HPCI ID and the HPCI account to use the HearDesk resources. And after that, from the next stage, maybe most of the people will use the HPCI system as a beginners. And at that time, we already distributed the HPCI ID and the HPCI account. So it is quite easy to jump into the HPCI business or HPCI research construction consortium in Japan. So I think this is a kind of a win-win model, where first we will use a current HPCI ID for the people who already have it. And we will promote the HPCI system through the HearDesk program. And finally, they are jumped into the national GPU computing. So networking is, there is no word to add. So networking of the various fields is so important. And we have a GPU technology and also GPU programming languages as a common language to discuss. So for example, the astrophysics or particle physics or material science or climate science, everyone enjoys the GPU computing in some manner. But also they can share the libraries and some methodology or algorithm to use the GPU as a common language. So sorry for the next 2 slides is in Japanese because the government provided us only the Japanese version. So there are 2 programs just started. One is called AI for Science. And it is translation is that innovative scientific research by AI for Science. And this is a really big project because in total, in next 3 years, the government put the money about $240 million US. And it is announced that up to 15 teams are selected, and every team has about $30 million per 3 years. So this is a 3-year project. And more surprising one is that the government also announced 1,000 teams will be selected for just 1 year, one-shot project. Each one is not so big money, like $35,000 for 1 year. But it means that every young researchers, let's try the GPU computation under this program. So in total, $240 million US for 3 years. Next one is much smaller, which is called the Grand Reach. The Grand Reach means that let's reach to the grand challenge or something. So anyway, this is a follow-up program of the current Fugaku promotion program, where I'm one of the program director. And a grand reach is selecting up to 3 teams with $0.7 million per year by 5 years. So $3.5 million for 5 years. And also the smaller one is about $0.3 million per year and by 5 years and up to 10 teams and so on. So their budget is about 1 digit lower than the AI for Science, but it's still important for their development. Okay, so I have not so much time. So collaboration with the RIC and RCCS is also very, very important because they're a house of the Fugaku Next machine, as well as the Fugaku and the K-computer. And we have a very tight coupled collaboration and discussion every month to how to port all the Fugaku application to the Fugaku Next GPU application. And Hairdesk is clearly a partner of the RIC and RCCS. And I have many of the friends in the RIC and RCCS, of course, and Satoshi and Kento-san and others. And we are just next to next, 10 minutes walk. So I'm frequently visiting the RCCS, although Satoshi is not always there because he's traveling around the world. But anyway, that more importantly, and many other his guys are my partners. And we have a very good relationship, and next meeting will be the next week, I believe. And the Grand Reach is especially to develop the large scale applications, so that it is a follow-up to the Fugaku. Only the problem of the Grand Reach is that they can currently provide only the Fugaku resources. So not just the money, but also the big amount of the computation node resource. I believe that it's about 70 million node hour is provided to each project of the Grand Reach, the big one, Grand Reach big one. And unfortunately, still Japan has no big, very gigantic GPU system. Although the RICAN will introduce next machine, also named tentatively AI for Science GPU cluster, with thousands of the GPUs, but that is not enough to support all the computation resources. But anyway, at this moment, the government only provides a Fugaku node hour, but in the next step, a couple of years later, we will provide a much bigger GPU resources. So the international activity is also very important. And currently, we have some connection with the DOE Next between Japan and the United States, or a Hanami project between Japan and the EU, and E4S and other activities. And also there are many the centers, individual center or a collection of center like a DOE or Euro HPC JU or a JHPCN in Japan. So that we are now constructing all the good relationship with international activities. So GPU vendor support, also important. As I told you, NVIDIA and AMD fully support us and give all the materials under some restrictions. So the problem is that there are some materials under NDA. We cannot provide the NDA document or materials, but most of the education materials are based on the open technology. Just we select all of them and figure out what is a straightforward education course and making the text and the materials and the videos. And so let's move towards the advanced GPU code production for the science and also the society that the results shared in the world. So what I mean is that so far, Fugaku and the K-computer are Japanese-oriented own CPU technologies. So very unfortunately, there is no other machine using the Fugaku technology out of Japan. Even Japan, Fugaku exists, and only 2 medium-sized or small-sized systems are running with a small size of the Fugaku in the Tokyo University and Nagoya University. That's it. So that means that so far, governmental program to support the application development is mainly for the CPU-oriented. But in the world, almost no one uses that technology already. So we said, ironically, we call ourselves as the Galapagos. So Japan is a kind of Galapagos island, and there is a very good and unique research project exists, which is very highly tuned for the Fugaku machine. But unfortunately, all over the world is moving to the GPU. So that GPU computation opening that door means that we are reconnected to the world. And we can export our scientific or society application to the world, and we can import all the GPU-ready application from the world. And so we are bridging the world and Japan again under this project. So finally, give me a couple of minutes to just introduce the 3 universities and unique activities. So mainly HPC is for the University of Tsukuba, and AI in the Institute of Science Tokyo, and AI for Science by the University of Tokyo. But they are not limited on each university. It's just a list of the mainly they are very good at to have some research. And they collaborate with AI for Science for older. So all 3 university core members knows with each other, and we are friends. So University of Tsukuba is mainly focusing on their multi-vendor GPU. So University of Tsukuba is the only one national university who both have who has both the NVIDIA GPU and the AMD GPU running supercomputers. And we are developing some multiple coupling of or porting technology from the NVIDIA to AMD or AMD to NVIDIA, and basically the very interesting performance tuning and also the memory performance tuning. And this is just the introduction of my University of Tsukuba. So we are running the Pegasus system. That is the first Japan H100 ready system. And Miyabi-G is the Japanese first GH200 ready system. That GPU, CPU, Grasshopper super chip with 1,120 nodes. And this one, maybe I think this is the first time in the world to show this picture. So it is called Sirius. And a new machine, it is very small with only about 100 of the MI300A, but it is based on the APU. And I think that we will lead the AMD GPU computing in Japan. So by the way, we put an older some astrophysical object name. Before Pegasus, we have a Sirius. So Sirius, Pegasus, and not Cygnus. Cygnus, Pegasus, and the new Sirius are all the brothers in our center. And the University of Tokyo is very enthusiastic to promote the AI for science, and they are developing some very they're oriented, unique library called H3 Open BDEC, mainly led by the Professor Kengo Nakajima. And they are ready for all these kind of the different kind of data structure, like a structured lattice or a multi-body or an unstructured mesh, and so on. So that their goal is using the GPU technology to target all kind of the data structure, and also collaborating with the worldwide technology, like, for example, COCOS by the ECP, and so on. And finally, Institute of Science Tokyo, the former Tokyo Tech, are very good at for the AI research by the Ryo Yokota, and deep learning software stack is under development. And also, they are very curious about using the generative AI for the GPU computing or GPU coding. So we at first we thought this is just a research topic, but at this moment, so the coding by the generative AI is really rapidly improved, and we think that maybe we can use that technology not just for the research, but also the production level of the hair-desk code support or code shifting support in there. So I'm personally very curious about how the AI, generative AI, supports our GPU coding in Japan. Okay, so this is a summary of my talk. And first, Japanese supercomputing research is shifting from the policy of the made in Japan to made with Japan, because we will introduce the NVIDIA GPU at first time as a national supercomputer, the national flagship supercomputer system, as well as the Monaka X Fujitsu CPU. And all other center is going to use a GPU-ready system. And that's so far, Japanese most national projection of the product of the code is based on the OpenMP plus MPI, CPU-oriented. But we have to change very rapidly to the GPU in the next 3 years. And HERESC was established, and I'm currently the director, and I'm leading all the programs. And we are making the construction of not just a collection of the GPU materials, but also make some straightforward, easy to learn and easy to understand, and no failure on the GPU computation. That is our the strategy of the GPU education. And finally, we support all the application, top-level application by the governmental program under the Grand Reach or Air Force Science project. And that's my next 4 years. By the way, this mission is limited to the next 4 years. So personally, I retire from the university in the end of March, but I will continue to work in the HPC, AI, and AI for science for the next 4 years. So that is my new life in the supercomputing. Thank you very much.